Hello, a very good morning, students. Today we are going to start the another important chapter or another branch of mathematics, calculus. In class 11, generally we have to face the two chapters, limits and derivatives, and both the chapters are the basic parts in class 11 for the calculus. In class 12 syllabus, most of the syllabus are including the calculus. So let us start the chapter limits. First today, introduction of limits, the concept about limits. With an example, I want to discuss what is limit and the different properties of limits. At first, say for a general function y equal to fx, you know y is dependent variable and x is independent variable. If we consider the particular examples, particular function, say fx equal to 2x or y equal to 2x. You see, I have taken a table, the different type of values of x. For this function, when the values of x, I am going to consider x greater than 2, but be careful, though the values of x I have taken like 2.1, 2.01, 2.001, first these three values. You see, the values are all greater than 2, but the values are very close to 2. Now, 2.1, 2.01 and 2.001, out of these three from right side of 2, so this is a number line, this one is 2, this is 1, this is 3. All the values I consider closest to 2 from right hand side. Out of these three values, if I ask you who is closest to 2, the third value 2.201 or 2.001 is closest to 2 out of these three values. If I ask you, you say who is the or tell the closest value of 2 than this. Say one student saying the answer 2.401. The value is more closer to 2 than this. So like that, if I take like 2.5 knots or 1000 knots or 100 knots or 1 lakh knots, then 1, the value will be more closest to 2 from right side. So like that, whole the day, if we try to say the closest value, this type of one closest value of 2 from right side, we cannot say. Only we have to imagine that that's very close to 2 from the right side, the value will be what? Similarly for left side, out of this 3 value from left side I have considered, out of this 3, the closest value this. Now, when x equal to the closest value 2 from right hand side, this one in calculus or in limit, this type of all values, generally the denotation we will give x tends to 2 plus. I repeat, x, this symbol is tends to. X tends to 2 plus means more than 2, very closest to the values. Similarly, 1.9, 1.99, 1.999 and so on. The values we denote in short x tends to 2 minus, and all this in general will say x tends to 2 for both, maybe from right side, maybe from left side. We are doing, or we want to know what is the limit for this function when x tends to 2 under this condition. Now see, in the table, when this type of values, x greater than 2 but closest to 2, x less than 2 but closest to 2, we are going to consider the different values for the function y or for the function 2x. What about the values? You see, all these values like 4.2, 4.002, 4.002, etc. These are the values all coming nearest to 4. You see the values, this, or from left side, this. All the values are nearest to 4. If I consider 4 is the boundary, 4 is the wall or boundary, all the values for x tends to 2 for the function y equal to 2x are coming either this side or this side of this border or this boundary. So 4 is the boundary or the border. 4 is called the limit of the function y equal to 2x under the condition x tends to 2 or x tends to 2 plus or x tends to 2 minus from either side. So what is the limit for this function y equal to 2x under the condition x tends to 2? The limit is 4. What is the general denotation? Look at the board. Limit symbol generally we use LIM or sometimes only LT. This is the symbol of limit. X tends to 2 of the function 2x. The limit is 4. In general, for a function, we'll write a limit x tends to a of fx equal to L. Here, L is 4. I think it is clear. I repeat, for x tends to 2, for the function y equal to 2x, the limit is actually 4. This boundary value means nearest to what? The value for different values of x, the values of the function coming. Who is the border? Who is the boundary? That one is the limit. So limit is 4. I think it is clear. Now, limits are generally two types. What are the two types? Try to clear. I have taken few values from left side up to like 1.9, this. Generally this one denoted by x tends to 2 minus. This limit is called actually left hand limit. And similarly, x tends to 2 for this, for the function when we are going to consider x tends to 2 plus from right side of 2, for the function we are going to consider the value, the limit will be RHL, left hand limit, right hand limit. For the condition x tends to 2 minus means less than 2, x tends to 2 plus for right hand limit for the function, it is called x tends to 2 plus means the values of x greater than 2, this one right hand limit. And not only that, one important condition you can take note, when for a particular function the left hand limit and right hand limit both are equal, then limit will exist for the function. I repeat, when left hand limit and right hand limit both will be equal, then for the required function the limit will exist. If both are not equal, the limit does not exist. For example, try to clear. So limit question is given whether the limit exists or not. From your book, I am taking the question. Say it is given limit LT, limit symbol I said, x tends to 0, 1 by x is the function. Firstly, if I try to calculate left hand limit, I said the left hand limit symbol limit x tends to, in general value a minus. Actual meaning is try to clear. For this, actually we will take x equal to a minus small h. Be careful. H is a minus small h. H means the very, very smaller value nearest to a. I repeat, h, small h is the very, very smaller value nearest to a. And at that time, if x tends to 0, h also tends to 0. And that time, what we will do, this one for the function is x, 1 by x. Actually, our example is 0 minus. Now, if I consider like x equal to a minus h, then we can write limit h tends to 0. If x tends to 0, then h is also that. Then, and here a is actually we have 0 for the question. Then, if x tends to 0, h is also tends to 0. And what we are getting, there is 0 minus 1 by 0 minus h. 0 minus h. So answer, and you know when limit this one is equal to minus h, if I substitute h is 0, it is undefined, or we can write minus infinity 1 by h infinity, and minus is same as that. So it is left hand limit. If I calculate the right hand limit, then what is coming? That is equal to limit x tends to 0 plus of the function 1 by x. Again, instead of our right hand limit, we can write x equal to, here a is 0 plus h. You see, when h x is 0, h x tends to 0, h is also tends to 0. So in the next step, we can write limit h tends to 0 and 1 by 0 plus h. So finally what we are getting, if I substitute direct value, then 1 by 0, we are getting positive infinity. So what is left hand limit value? Left hand limit value is negative infinity. What is right hand limit value for the function provided limit x tends to 0 is plus infinity. Both are unequal. So limit x tends to 0, 1 by x does not exist, because both the left hand limit and right hand limit are not equal. When they will be equal, I told the limit should exist. Now, the different function, the limit. Firstly, I want to discuss for algebraic function what the properties, not only for algebraical function, properties for different type of functions. What is the property? Firstly, the properties for different function. Number one, when the limit, any limit, in general I am writing limit x tends to a. Say there are 2-3 functions, or firstly I am taking two function fx and another function gx. In between them the sign is plus or minus. Now, what is the property? The limit will be distributed, or we have to divide the limit. We have to take the limit with both the functions separately. So property is limit x tends to a of the first function plus or minus limit x tends to a of the second function. The property also for the function when they are as a product or as a quotient. What? Look at the board. Second property, limit this function into this function, or at a time I am taking a quotient function, division function like phi x. You see, between the three functions here into and here division sign given, limit also will be distributed with all the functions like limit of first into limit of second divided by limit of third. The limit we will take with all the functions. When we will do the sum, we will apply it. Another property, say a function limit x tends to a, same limit I am using in general, and a function with coefficient like k is the coefficient and any function is given. To calculate it, as with constant term of k, the coefficient of fx, there is no x function, so it will be same as that, and limit we have to distribute with the function where x is present. So this is another property. I think it is clear. Now, what type of sums we will get, we will face first. Try to clear. Today, only few short example I am going to discuss. What? Say, for different algebraical function, first we have to face the direct substitution or sometimes factorization or rationalization for algebraic function to calculate the limit. What type of sum? Try to clear. Say question number 1. Question language. Now only one question language. Evaluate the following. So question is given limit, very simple sum, x tends to 2. Say a function is given 3x square minus 2x divided by 2 plus or 2x plus 1. You see, direct substitution. If I substitute x equal to 2, direct substitution, you can put x directly. But first you will just substitute the value. If quotient function is there, then x equal to 2 here, you say denominator is not coming 0. So when denominator is not coming 0, you can substitute the value directly to get the answer, like 3 into 2 square minus 2 into 2 divided by 2 into 2 plus 1. So answer 2 to the 4th is a 12 minus 4 by 5, that is 8 by 5. It is direct substitution. But sometimes the direct substitution is not possible.